This graphic is entitled Sodic soils. Sodic soils are those with pHs from 8.5 up through a high end range of perhaps 10 or 10.5. Very seldom do we see soils with a pH of above about 10.5. Sodic soils are caused by an increasing concentration of sodium ions in the soil solution. Therefore, if we have increased the concentration of sodium ions in the soil solution, we must see a corresponding increase of sodium on the exchange sites. You'll notice that this high pH, this would be typical of a soil with a pH of about 9.5. At this high pH range, we do still see some other basic cations like potassium, calcium, and magnesium occurring on the exchange sites. What we've done then is displace the hydrogen with the sodium. So at this pH, we see very little, if any, hydrogen. This diagram is representing one hydrogen right here, but we have an appreciable amount of sodium now occupying the exchange sites in this particular soil. Would this be desirable or would it be non-desirable? Well, if we think back about the most desirable pH range for the growth of plants, it was from 6.5 to approximately 7.5. So obviously, if this pH is representative of a soil, a sodic soil at a pH of 9 or above, then obviously this would not be a desirable process to have occurring in the soil in terms of plant growth. Why is that? Even though we have an appreciable amount of basic cations here, sodium actually becomes antagonistic to the uptake and utilization of these basic cations, such as calcium and magnesium, by the plant. So not only does the high pH detrimentally affect the growth of the plant, but sodium also enters into the exchange reaction, and because of its high concentration in the soil solution, can actually become antagonistic to the uptake and utilization of the essential basic cations, such as calcium and or magnesium.